Hi, everyone. Welcome to this brand new episode of the Clear to Send podcast. I am joined here with our co-host, Francois. How are you doing, Francois?
Very good. How are you, Roel?
I'm doing very well. And we have a special guest, Ryan White from Celona, who's going to talk to us about private 5G and its role currently for us Wi-Fi guys, what we should know about it, and how it can help us in our environments that need something a little bit more reliable or more, I don't know, like better performance over
Is
private
it
5G.
the 5G we get with the vaccine?
Yeah, I'm all good. I'm all good. Private 5G right here. Brian, how are you doing?
I'm doing very well. How are you guys?
It's great to have you here. Thanks for joining us today on kind of early, I guess. I'm not sure where you're at, but why don't you give everybody an introduction of who you are and what you do? Let us know what you're all about.
Yeah, so my name is Brian White. I'm Director of Systems Engineering here at Celona, and I pretty much handle customer deployments, customer interactions, and kind of that initial education, consulting, sales phase of the product with regards to customers. Been doing Wi-Fi for many years and started pre-standard stuff and did one of the first large corporate deployments that was multiple thousands of APs, and that was 2099, 2000 kind of time frame. So it was really, really early. And then I was one of the first group of SEs to join Aruba Networks. I joined in 2004, spent 11 years there, and then was in product management at Mojo Networks, which was sold to Arista. And then I peeled out about a year ago, maybe a year and a couple months ago, to join some ex-colleagues of mine, Rajiv Shah, Ozer, Vinay from Aruba, and they had started a private cellular company with many other folks from, say, Qualcomm and other cloud companies, and thought it was very interesting. It was, a lot of the same use case, solutions that Wi-Fi was really going after for years and years, but with a special, kind of a difference there that made it very intriguing. And I think if we're Wi-Fi professionals, we all have been in situations where Wi-Fi did the job, but it was very painful to get to a stable, kind of end result, or whether I needed just a bit more reliability as the network loaded up. And these are all things that private cellular kind of promises the industry, or the customer base there in the enterprise. And I thought it was really interesting, and wanted to come along and be part of both educating the market on this type of product and working it into deployments that require reliable mobility. So.
Yeah, and we've had Celona on the show in the past. We had really good discussion about private cellular in general. How would you, and Celona is not just doesn't just provide the hardware. You guys have a whole software solution integration. You're trying to make it as easy as possible for the customer, so you can provide a turnkey solution. How would you present Celona if you were to present the company to people who had never seen you guys before? And then also another question that goes along with that, how would you define private cellular or private 5G, even if we want to use the buzzwords?
Yeah, and I think when I'm describing the systems to enterprise customers that maybe don't have cellular knowledge. I mean, it's kind of funny, you use the word cellular, immediately people think of cell phone, right? And they start walking down that path mentally. It's, what about my SIM card and how do I roam and all this stuff? And really what I try to do in speaking with customers is get them to kind of back away from that mentality or that vision of a cellular network, which is what we've all used for 15, 20 years now, with our own personal devices, and get them to stop thinking about it that way. Start to think about it as an alternative wireless data network that just happens to use different protocols to accomplish similar functions. And those similar functions can be, kind of maintained or brought to fruition using the benefits of private cellular technology in comparison to Wi-Fi. And what I mean by that is start to kind of look at use cases where Wi-Fi has worked but has traditionally been hard to attain positive, really truly positive success. And some of those challenging environments are manufacturing, ports, automated guided vehicles, maybe even voice communications like clinical communication systems in a healthcare environment. These are all places Wi-Fi has done the job for many years, but there's always this kind of like, oh, but it doesn't work when I do this, or oh, I always have trouble when the AGVs or the forklifts move from this area to this other area, or when they go fast enough, the mobility doesn't keep up with Wi-Fi. And these are the kind of the first kind of scenarios where private cellular can be really advantageous, because everything is infrastructure controlled versus within Wi-Fi, everything is really client controlled. It's the client device that decides which access point am I going to associate to. When should I transmit? Remember, I'm listening before I transmit. That's collision avoidance. And as more and more devices speak on that particular channel, people can't get a word in. I always use the example of 50 people in a room all trying to talk at once, trying to get a word in. It's kind of chaotic. Yes, you can communicate. That's not the question. You will get your point across, but you might have to say, what was that? I didn't hear you. You might be stepping on other people. Versus with LTE, it's this really regimented, scheduled communication system, right? So even with Wi-Fi, it's the client device that figures out when I should roam. The term roam in the Wi-Fi world is moving from AP to AP. In the cellular world, that's handover. In the Wi-Fi world, it's the client that decides that, and in the cellular world, it's the infrastructure that decides that. So because of that infrastructure control, you have very reliable handover or roaming between access point to access point. You have very controlled access to the medium because it's scheduled. And what that does is it creates predictability, wire-like predictability and reliability of that wireless network link. And that is traditionally what is lost in Wi-Fi. Wi-Fi works and it works very, very well. But these conditions, there are certain conditions, certain environments where it is really challenged. And so that's kind of the first kind of iteration of customer use cases with this type of technology.
So you guys address a lot of these shortcomings in Wi-Fi, and you have this control over the infrastructure plus the devices because you're using SIM cards. You know where each device is or what's on the private 5G network. On top of that, there's less interference to deal with, right? So we're not having all these different IoT devices or devices that are non-Wi-Fi operating on the same frequency. But you're really addressing applications that need low latency, reliability, that dedicated scheduling. So if a certain amount of airtime that is required for that application, you can dedicate that for that application, right? And have this QoS, an actual QoS policy. Is that kind of correct?
Yeah, and I like to use the word predictability, and I think that's the key here. Is with this type of networking technology, you get predictability. You may not get the lowest latency in the world, but what latency you see will be dead predictable, even as the network loads. I can enforce that predictability. I can enforce that quality of service. Really, no matter how loaded up the network gets, I can guarantee bit rates to certain classes of devices. Interesting thing on the SIM you mentioned, and I tend to try to get people to think about the SIM card in a different way. I hear a lot of customers or people, talking about it like, oh, I need a device that supports SIM. Well, the SIM is just the cellular. It's what the cellular world has adopted as the chip that holds the authentication credentials, right? And so the SIM is a portable way to move those authentication credentials from device to device and so on. There's nothing like inherent, like, oh my gosh, I have to support SIM. It's really about the cellular authentication method. And the SIM card, it just happens to be the way that the cellular industry has chosen to store authentication credentials. Think about it on the Wi-Fi side is, where is my certificate? It's in my certificate store, right? I just don't have portability, and that's what the SIM card gives you. Now, in the cellular world, there's a new thing that's relatively recent called eSIM, which stands for embedded SIM. It's a SIM storage unit within the hardware. And the SIM credentials, the cellular network credentials, are then delivered to that device electronically. So it makes onboarding a bit more similar to, say, Wi-Fi onboarding, when you're automatically, say, onboarding an ETLS, certificate-based client. It's more apt to that, because I think when enterprises start doing this in mass, and I have 5,000 devices, oh my gosh, I've got a stack of 5,000 physical SIM cards that I have to put in every one of these devices. It starts to get a little unwieldy. So I think that eSIM is going to grow in popularity because of that.
Could you have eSIM on a laptop?
You could, if it supported it. Yeah, absolutely.
So it's not really in a hardware component; it's more software component.
It is a hardware component. So it's
okay.
It's kind of a SIM storage area that's within the piece of hardware, right? So
okay,
a laptop could support eSIM if it was done that way. That's a good point. I don't know if the new laptops that have embedded cellular support eSIM or not. Speaking of laptops, and I've mentioned this before, I think it's really funny because from like 2007 to 2012, 2013, like every Lenovo laptop I ever got had a SIM card slot in the bottom, and it had a wide area modem in it, and I used it all the time. And then that kind of faded away, and now what's the new thing? Oh, these laptops support cellular networking. Like they've been
they've been around.
They have, but it's almost like that when LTE came around, like they stopped doing that. All my old laptops that had 3G support, they had where the SIM card slot in the bottom near the battery. I just thought that was kind of funny. It's like everything old is new again, to a certain degree.
And I know you guys on your site, you keep a list of all the supported devices. We've shared it in the past. Maybe we can share it again here. Talking about the technology behind the private cellular, I guess architecture. Which could you go in detail in which frequency band are used? What's the difference between CBRS, private 4G, private 5G? Would you be able to kind of clarify all of this for the listeners?
Yeah, absolutely. So CBRS it's not a protocol, and it's not really a technology. All CBRS is the FCC, the United States, Federal Communication Commission. That's their name for the band 3.55 to 3.7 gigahertz. So there's no this is a CBRS system, or it's not international. It's just really that frequency in the US. The technologies that run on that frequency are LTE, 4G, or 5G. So it's the same frequency, regardless of which flavor you use. You're still in that 3.55 to 3.7 gigahertz frequency range. Internationally, that will most likely be different frequency ranges depending on which country, which regulatory body approves which frequency range for private cellular networking. Probably some of the ones that are furthest ahead are the UK, Germany. I believe Japan has some movement toward opening up frequencies for private cellular, but they may or may not be the same frequency range that's used in the US and referred to as CBRS.
That's good to clarify. And how do you guys handle all of these differences in countries and regulations in the back end? That must be a lot of work, no?
It is, but remember, think about Wi-Fi. I mean, Wi-Fi is the same way. And in a past world, when I was doing product management, one of the responsibilities that I had was, international regulatory certification, and going through the process of getting your Wi-Fi access points approved in Morocco and Kazakhstan and Singapore and all of these, and you typically go through all of those hurdles when you release Wi-Fi APs on the market. So usually it's done in tiers. Like I'm going to focus on EMEA or the EU and the United States and Canada and Japan or and China. Maybe those are your tier ones. When I release gear, that's what I support. And then from there, I go into other levels of countries, and then you kind of fill in as your customers need and so on. It'll be the very similar process with private cellular. The big difference, though, is that early on, and I'm really curious on the history of this, and I don't really know how the global regulatory bodies settled on Wi-Fi frequencies being pretty much standardized across the world. I mean, yeah, Japan got 14 and Europe got 12 and 13 early on, but for the most part, it's homogenous across the world. Private cellular is different because everybody's kind of doing different things, different frequency ranges and so on. So it's going to be, I would say, a bit more challenging globally, but it's going to happen. And I think what will end up happening is very similar on the private cellular space as Wi-Fi space. Is a lot of the vendors in the Wi-Fi space, when you bring up systems for the first time, you tell it which country it is deployed in, and then therefore it inherits the regulatory rules and regulations for operating within that regulatory domain. So I suspect the cellular world's going to be very similar. It's just not quite there yet.
So if you have like a wider range of frequencies to support, do you guys, like, how do you handle this in the hardware? Do you have like a SDR radio or something, or?
Yeah, well, the hardware has to support those, those frequency ranges.
Okay.
Kind of ahead of time.
Yeah, you
and
can't
then
just
from there,
slide a
it's
SIM.
software configuration. So.
Okay. Awesome.
Yeah. So how do you see the ecosystem developing right now? There, I assume there's probably someone would have to decide. All right, if I want private 5G, CBRS, you name it, they decide upon that, and then they have this use case, but then they need to determine device support, or do I need to bring in new devices? How do you walk someone through that so that way they can plan accordingly?
Yeah, great question. I kind of break the CBRS supporting or private cellular supporting devices kind of into three buckets, if you will. There's the first bucket is the native support, right? It's an iPhone, it's a Google Pixel 4, it's a iPad Pro, especially modern ones, the ones that have been released over the past couple of years. If they were released in say mid 2019 or later, typically they will support CBRS. Just a pause there. What you're looking for really is the device is supporting LTE right now with the products. Let's take LTE as an example. Let's say I have a device that supports LTE. So now the question is okay, great, it supports LTE, so it supports 4G. Does it support the CBRS band? So what you'll look at is in the LTE spec, you'll see it either listed flat out CBRS. The other term for CBRS is ONGO, ONGO. And the CBRS Alliance, which was an industry consortium, geared toward, private cellular adoption, they kind of used the term CBRS for a long time, but obviously that only is referencing that one frequency range. So they renamed themselves ONGO. So you may see CBRS, you may see ONGO, and you may see LTE band 48, all the same thing. It's that 3.55 to 3.7 gigahertz. So if you're looking at devices that support LTE or 5G, you're looking for that term CBRS. In 5G, it's called N48, and that's the same frequency range as band 48 in LTE. So you're looking for that. That's number one. So these native devices would have those supports, whether it's a laptop or an industrial tablet or a cell phone, a mobile device or whatever. You're looking for that support. The next piece are devices that allow other networking technologies to be the end connection method to the device, but its backhaul is using private cellular, CBRS, 4G, 5G, whatever flavor it's using. I look at those as, say, Cradlepoint, Sierra Wireless. There's a few other models out there. These are devices in Cradlepoint's case, and both Sierra, they've been around for a long, long time. They handle vehicular communications or branch office communications, and they're branching out, no pun intended, to other use cases as well. But what will happen with that is I have a device that has Ethernet ports or Wi-Fi, and I have a cellular backhaul off of that router. And so that's used quite commonly when, say, I need to connect a vehicle to a private cellular network, or I'm a college campus and I want to do outdoor classrooms and I want to light up this quad area with my Wi-Fi network. Because remember, all the students coming in, they're not going to support the private cellular network. So they're going to support the Wi-Fi network. So it makes it easy to onboard clients, even though I'm using the range and reliability of, say, a backhaul system. And then the last little bucket are kind of the bad word. You use them as, you term them as gateways, but I kind of refer to them as adapters as well. But there's USB flavors, but it's just the little box, little tiny things. Maybe it's LTE on one side or 5G, and then USB. And I plug that USB into a laptop or some other device. They also make Ethernet versions of those. So that means any device out there on the planet that has a wired Ethernet port can magically use a private cellular network by using one of these devices. It's about the size of a deck of cards, Ethernet on one side, private cellular on the other, and that device is now on my network. So yeah, all of those things you kind of discuss with the customer, discuss with the end user, and talk about the best way to bring whichever device is required onto this network.
Yeah, there isn't a way where it's like, all right, I have these devices, they don't have SIM slots, they don't even support these frequencies, and then it's kind of end of conversation. What you're coming up with is, hey, we do have a solution where you can add these devices. You just need to either use this USB dongle that uses CBRS backend, or a router that they connect Ethernet in. It's all backhaul is what they would use. I think that's a great way to integrate some of your existing technology. And I really like your campus, the campus discussion there, where it's very expensive to do any kind of backhaul, like wired backhaul to an area of the campus where there is no connectivity, right? You need power, cabling, you know, mount stuff. You remove the trenching portion of that, right? Which is usually the most expensive piece. And then you have your antennas that can provide a wider coverage, much wider than a Wi-Fi access point. And you're just using, say, CBRS as a backhaul, but then attached to that antenna, you would have maybe an access point to provide Wi-Fi for all the Wi-Fi capable devices. So I think that's a interesting way of trying to integrate private 5G, CBRS, whatever you want to call it, into your existing network without trying to, how am I trying to say this? Like, you have more options basically. And you don't have to rely on maybe these Wi-Fi point to points, which can be limited, right? Because if you're shooting 5 gigahertz through a campus between buildings and whatnot, like it will see other channels, right? It will see other networks around. So I think having that reliability with private 5G as a backhaul is a nice option.
Yeah, and if you're using higher frequency like 30 gigahertz, you're weather impacted a lot, and so those are other things. I think one of the interesting aspects of CBRS, private cellular over CBRS, is the FCC laid out rules for indoor access points and outdoor access points. And indoor access points are considered what's called a category A, and they have a max EIRP of 30 dBm. So it's very similar to Wi-Fi in that regard from a power output perspective. But in the outdoor, category B outdoor devices allow up to 47 dBm EIRP, so which is 50 watts, which is massively different than what I can do outside outdoors with a Wi-Fi network. And I think there's a lot of interest in CBRS, even if maybe the customer doesn't have a use case to do it indoors. There's a lot of interest in, hey, I'm going to light some stuff up outdoors to support push-to-talk communication, vehicular, campus security. Maybe I'm, lighting up parking lots for vendors, or all these types of use cases where I get this longer distance.
Yeah, for sure. Especially like campus buses, right? Getting them connected instead of having to use like LTE all the way back to the tower. They can actually connect to your network and have that as an option.
Yeah, and a couple points there, which are really important. Two things: when you're doing things like this with cellular backhaul, especially if I'm in a contained area, and you're using an operator's network, you're incurring data costs, right? So number one, it's a costly thing. Number two, though, is that data is going through the carrier network, the operator network, and then coming back to your network. And yes, they can secure it. There are options to do VPN and back, but from a data sovereignty point of view, a lot of the interest in private cellular is, I have this area, I'm currently covering it with an operator, I'm paying a lot of data charges, I would like it to be a private network as well. That data always stays on my own network. It's a private network, just like my Wi-Fi network goes into my corporate network, or my cellular network can do the same. And those two things are really what drives a lot of interest in outdoor, especially, and indoor as well. But indoor Wi-Fi is a viable solution. Outdoor Wi-Fi is a problematic solution. Yes, it works, but there are limitations, mostly due to the power output and wide channel interference and all these other things, other access points in the area and so on, as you mentioned.
So when it comes to number of access points you guys would need, I don't even know if you call them access point, I can't remember, or nodes. I'm guessing that would be less than Wi-Fi, obviously. In terms of cost, how would they compare to like Wi-Fi access points? And also, do you have to think about any licensing costs to be able to use those frequencies? I guess that would depend on the country, but I don't know if you can give us some insight.
So let me I'll cut that into two answers. The first answer, you're talking about number of access points in comparison. So we tend to use at Celona, we tend to use the word access point. The cellular industry for a 4G LTE device uses the term eNode B, evolved node B, and then in 5G it's G node B. But it's from a practical perspective, we term them as access points. It just makes it easier to talk about, especially with enterprises who are used to that terminology. From a
you don't use WAP?
Do I?
You don't use WAP?
No self-respecting wireless LAN WAP.
Sorry.
Yeah. Anyway, so from a number of access points for a certain area, it's so for indoor, you're talking about the same power outputs generally for indoor as you do with Wi-Fi. But the difference between a cellular device is that cellular radios have and cellular kind of antenna systems result in a very high receive sensitivity. So a cellular device can decode a packet and at a much lower signal strength than what a Wi-Fi device requires. Like a Wi-Fi device requires, we all know you're designing to neg 65, neg 67. Starts to get above neg 70, I start to get performance issues, and then I'm by negs 72, 74, I'm pretty much out, and I'm moving on to the next access points, which requires me to have a pretty dense deployment. In the cellular world, there's a term called RSRP, receive signal power level, and we're looking at neg 110, neg 115 before these things start dropping off with unusable. And even at that low signal strength, from a downlink direction, you can get 15, 20 meg sometimes, and it's depending on the device and the environment. So it's obviously uplink is a lot lower, but a lot of the applications are downlink heavy. But anyway, so that's part of it. Is the part of the reason why I need less is I have this really high receive sensitivity, and indoors it's from a power level similar to Wi-Fi, but in the outdoors when I'm doing 50 watts, then it gets the distances can be fairly far, and it depends on the terrain, it depends on the buildings, depends on the trees, and sometimes I'm doing design where it's a challenging environment, a challenging terrain, and I'm doing 450 meters before things go sideways. The other side of that is I have complete total flat terrain and great line of sight, and I'm getting really good performance at 1.6, 1.7 kilometers. I've even done a voice call, which is kind of crazy, at upwards of 4 kilometers.
Wow.
which was kind of crazy. It was a flat piece of land, and it just the signal, you know, kept going and going. But I wouldn't say that's normal, so don't go and say, oh yeah, 4 kilometers. But I mean,
4
it's
kilometer, that'll work for anyone.
yeah, exactly.
It's crazy it even works.
Yeah, that's
And
really
see,
interesting.
that's what I thought. It was like we were sitting out there kind of going, you know, it's crazy that it even worked. But and actually, to be honest, it was 4.7 kilometers to be really exact. So it was quite far. But anyway, so where all of that stuff basically means that when you're doing a private cellular network design, especially indoors, the rule of thumb that I see, depending on the environment, is anywhere from 3 to 6 Wi-Fi APs for every 1 private cellular AP. Right? There are instances where the configuration of the building or the wall materials, I need to go pretty dense. It almost looks like a Wi-Fi network. And then there's other instances where it's a more wide open floor plan or whatever, and maybe I space them out quite a bit more. So.
Yeah. So speaking about these deployments, how do you address questions or concerns from people who, one, don't have any knowledge of cellular at all? Because now that we're talking private 5G, CBRS, I own this network. That must mean I now have to learn a lot of new technology. There must be a high learning curve, different frequencies. Is it difficult to deploy? Like, am I going to have to spend a year or two trying to make this work?
Great question. And I would say it depends on the path that you take toward realizing that network. And the way the cellular architectures are kind of governed by a loose consortium body called the 3GPP, and they're in charge of standardizing cellular systems, and they're the ones responsible for 3G, 4G, 5G, and so on. And with those architectures, there are different components that create that entire service. So if you think about 4G as an example, there are various pieces to the puzzle. There's the gateways, the data path itself. There's the HSS, which is the home subscriber system. That's the authentication backend. So if you're a wireless guy, think that's the radius server, and that's where I have all my usernames and passwords and so on. I have a SON, self-organizing network. There's functions that say this is how these networks self-organize into different channel and power levels and so on. Think of that as radio resource management in the Wi-Fi world, right? So there's all these different pieces to the puzzle that in a cellular world are different applications, generally from different vendors, that are brought together by an operator and integrated in together as an operator so that they can put together the Legos to make a spaceship or a fire engine, right? So it's like you have to have the knowledge to put all that stuff together. Operators have that domain knowledge, right? And they've had it for years. They've been building these networks for years. If I'm an enterprise, I don't have that domain knowledge. So what do? Do I go to the radio vendor and buy an access point, and then I go buy an evolved packet core from this person over here, and I evolve, and then I'm the one that has to learn it. I'm the one that has to put it all together. And this is kind of where Celona is different, because Celona was built from the ground up to be an enterprise-friendly 3GPP standards-based, cellular networking system that is deployed in a way that enterprises are used to, right? As an enterprise, I'm used to, here's my wireless LAN controller, and I'm going to put APs, they're going to discover the controller, and I have some management system, right? Well, what happens within that wireless LAN controller? What goes on? The data path goes on, the authentication goes on. All of these little parts and pieces are just contained in this one piece, right? And this is kind of where Celona comes in, is the architecture is the 3GPP architecture, but how all of those services are spun up are within Docker containers in a Kubernetes cluster. So as an enterprise, I'm just spinning up a VM. I'm not spending time integrating all these pieces together. I'm spinning up a VM or I'm installing an appliance. My access points discover the location of that server, and they're all managed via a cloud management UI. So as much as possible, what Celona is doing is making this relatively complex cellular networking architecture look like your typical enterprise networking system,
Mhm.
right? Just like your Wi-Fi, just like your cloud managed firewalls or whatever. And I think that eases the transition, especially in the enterprise, with jumping into the private cellular world.
So it looks like it's cloud managed private 5G.
Yes.
And so a lot of it is automated and abstracted from someone like me. Like for me, it's more about, all right, I need at least a VM or appliance on site so the APs can talk to that, but then I can manage everything else in the cloud. So there are a lot of pieces that I don't really have to know the nitty gritty because you've already done that portion for me.
That's correct. Yeah.
Okay.
Yeah. Right. So the APs will, figure out what channel and power they need to operate on. So I don't have to configure that stuff manually. From a SIM, from a device and SIM perspective, that authentication system is built into the UI as well. So I'm just going in to that particular SIM card identification number, clicking activate. I maybe add it to a device group and map it to a VLAN. It's very straightforward, very similar to any other system there. So it's makes it really enterprise friendly.
Yeah, I remember we did a demo last time we had Celona on, and it was very easy. I was surprised. I was like, "That's it."
Yeah. I was at a customer site the other day, and they were just like, "Oh yeah, okay. Once everything's up, we got to get in there and configure it." And there was really no configuration. You're basically just activating your SIMs and mapping them to VLANs, and then off you go. And I think that the impression is it's hard. There's some optimization, some configuration that they're going to have to learn and do. And we're trying to automate that as much as possible. And yes, we get into situations sometimes where it's like, okay, yeah, for this, we need to configure it differently. And this is all on the back end, right?
Yeah.
There are situations where that comes up, but we're really trying to abstract that complexity from the customer, as much as possible. So.
Yeah, I guess that's one question I had for you, like more on the software side of things. What are you guys doing? Or what new features are you guys working on to kind of automate some tasks, or maybe make it easier for the end consumer to deploy and use those systems?
Great question. I think the biggest thing coming up very, very soon is eSIM support for private cellular. So instead, like right now, when you purchase a Celona product, you get X number of physical SIM cards for every access point that you subscribe to. We sell it all as a subscription service, and so for every indoor AP you get 20, for every outdoor AP you get 40. So again, you get into that physical situation of I have to now insert all of these into the system, and so I think with private networks, eSIM concept is going to be very, very popular. So in the next couple 3 weeks, I think we're releasing our first eSIM support within the system. And you'll basically be able to take a mobile device that has an integrated camera and go to a QR code, or scan a QR code, and that kicks off an onboarding process for that device to digest the authentication credentials and store it in the device's embedded SIM.
What about this edgeless architecture? I know that's something new from Celona. I've seen it on the website. I don't understand the concept of it because we've talked about having something on site or on-prem.
Yeah.
Can you explain that?
Yeah, it could still be on site and on-prem. It's the concept really is about networks that are deployed in a modern cloud centric way. Or what's the term? They use cloud native as the term. Which personally, I think that's the industry. That's not just Celona using that term, cloud native. The industry has started to use that term, cloud native. I think that's a confusing term because when you use the term cloud native, I think it construes that it's cloud-based, and it doesn't necessarily mean that. What it means is that I almost like the term cloud principles better, in that what that means is the principles and the architectures that I use to build applications in the cloud, modern architectures, like when you go to Salesforce or when you go to Facebook, I mean, these are you're not just going to this one server. You're pulling information from various aspects and architectures. Microservices is the term typically, and these are the way modern cloud applications are built. In the enterprise, if I take those cloud principles, that cloud native architecture, and apply it to a network core, what does that mean? So by default, the Celona system is that anyway, because we're taking the different parts and pieces of the 3GPP architecture, spinning them up in containers and creating this service within the VM, right? And what if I had another microservice that was tied into that core that maybe handled firewall functionality or UTM functionality and so on? And maybe I had the flexibility of some locations I want that on-prem, but others I want it centralized in my data center, and others I want it internet-based. But it's all kind of one system from a management and operation perspective, and I can dictate where my data path lives. I can dictate, where these roles live within my network, and that's really what that means. And the alternative is I'm putting in a controller, I'm putting in a firewall, I'm putting in. You're very regimented from a network design perspective. And the concept of the edgeless enterprise is I can now disaggregate my entire network core into different functions or different microservices across an enterprise, and it really doesn't matter where this stuff lives anymore. I can dictate the data path from a software perspective. I can dictate the security functionality or anyway. That's basically what it means from a high level, and it's a vision. And I think in the traditional networking mindset, it's kind of like, whoa, what is this? But cloud applications are going that way. Software applications have been going that way for years, and it's becoming a very mature type of technology. And I think the networking vendors, I think all of them are really, truly looking at how to take a lot of those principles and apply it to a network core. And that's really what this is about.
It's similar to SDN, right?
On steroids, I would say.
Yeah.
Yeah, you're just taking.
It really is. I think that's the closest thing is SDN, but it's really taking SDN to that next level.
Yeah. Okay. So it's just taking cloud architecture, or how you build the cloud, how the cloud's currently built, but bringing that on-prem and doing that like a private cloud, really.
Yeah, but for network functionality, I think custom enterprises are already doing that for their own internal applications. They're building those internal applications in a cloud native, cloud principled way. But the networking functionality is still pretty siloed, right? I have my core, I have my distribution, I have these switches, I break it out to access switches. It's very regimented,
very specific appliances.
Yeah, I uplink into this firewall, and this segment goes here, and it's been that way for 20, 30 years now, right? So what's it going to look like in the future? And I think SDN kind of started on that path, and then later it'll become this. And a good example of what was, and this is aging myself a little bit, not that my gray beard doesn't do it already, but I remember 99, 2000, that time frame, it was Cisco and it was Nortel, and there was going to be this huge battle, and convergence was the word. You heard convergence everywhere. And at the time it was just like, oh yeah, I'm going to use voice over this data network and all this other crazy stuff. And it kind of faded. Like, people stopped using the word convergence. Then all of a sudden everybody woke up, and it was like 2010, 2012, and all of a sudden it was like, wait, all voice traffic is over IP now, and we don't even think about it today, and it's just the way it is, right?
Converged.
And I kind of liken this to that early days of throwing around the word convergence, and everybody kind of going, what is that? But things evolve and they become kind of the norm.
Yeah, we call it software-defined networking now.
Right. So like software-defined networking may have been the early term, of like convergence, and then it becomes kind of like, oh yeah, remember when we all called it software-defined networking? Now it's just kind of the way the world is.
Edgeless,
right? Right. So
just new terms.
Right.
All right. Well,
what did I say earlier? Everything old is new again.
Yeah, it's just recycle, right? Everything keeps coming back around, right? We didn't want anything on-prem, so we went cloud, but now we're like, that cloud stuff looks pretty good on-prem. Let's do that. So now
which launches an entire concept like MEC, right? Mobile edge computing, and like everybody's, kind of doing that now. So yeah,
So it's a cycle, but
it is.
I want to thank you for joining us here and giving us this like really interesting discussion around private 5G, how we could use it. It's very doable for people because even I'm thinking about previous projects I've worked on where Wi-Fi was a challenge, and now going maybe even having a private 5G backhaul might be very good solution, a good option, or even those like scan guns that are super critical in warehouses where they have problems roaming, or
Right.
the site doesn't want to deploy that many Wi-Fi access points.
Mm-hmm.
Maybe they have SIM cards that they can. I have seen scan guns with SIM card functionality, but it probably just doesn't support the frequency. But I know newer scan guns will start supporting that. Or
I suspect more will start supporting it because it's just, that's one of the use cases that just makes all the sense in the world, right?
Mm-hmm.
I mean, Apple's putting it in their devices, so I think even some companies will just start using iPhones as the device. They put the app on there and just use CBRS for the connectivity, right?
And some already do. Yeah, some already
exactly.
do, and even communication systems. People are there are like healthcare communication systems that already work on the iPhone, right? And so if their refresh cycle is caught where it's like, okay, I'm moving from my iPhone 8 to a new iPhone SE or an iPhone 12, great, you just inherited CBRS capability within that device. And would you like to roll out CBRS private cellular within your hospital to offload the voice communications from the Wi-Fi network, which incidentally creates more capacity on the Wi-Fi network for all of the other stuff, right? The devices that can't be cellular, that your guest networking and your X-ray machine or whatever. So the rising tide lifts all boats in that case, and they're complementary technologies.
Yeah.
So
yeah, and one's not going to replace the other. There's just very specific use cases.
Yeah, for sure.
All right, Brian, where can people find you and where can they learn more?
They can find me at brian@celona.io, and it's BRIAN, and Celona.io. Celona, incidentally, is the latter half of the word Barcelona, named after Mobile World Congress. So people always kind of say, "What, Celona?" Or they kind of try to pronounce it and they mispronounce it. Yeah, just right, exactly, right. They would just think of Barcelona and just the last part, Celona. So Celona.io.
Gotcha.
Can reach me.
I got a glass from Celona, and it has the map of Barcelona. I don't know if you've seen this one, Brian.
I've actually not, but in our office we have those kind of artistic city maps. We have Barcelona city maps in there. It's really cool.
Awesome. Well, thank you, Brian, for joining us. And if anyone has any questions, head over to cleartosend.net, look for the Celona episode, and let us know in the comments or hit us up on Twitter. But we want to thank you guys for listening. And Brian, thanks for joining us.
Absolutely. Happy to be here. And also I'm on the Clear to Send Slack channel as well. So you can contact me there.
Awesome. Thank you, Brian.
Yeah. Great. See you guys.
All right. Bye, guys.